Example 8. Find an equation of the plane through the points P1 has coordinate 1, 2, -1, P2 coordinates 2, 3, 1, P3 with coordinate 3, -1, 2. To find the equation of a plane passes through these 3 points P1, P2, P3, we need to find the normal to the plane n, which is perpendicular to the plane. How do we get this vector n? First, we observe that P1, P2 lies on the plane. So, P1, P2 lies on the plane, and P1, P3 also lies on the plane. Now we can do a cross product construction. If you take P1, P2 cross product with P1, P3, by the definition of cross product, we know this vector is perpendicular to P1, P2 and perpendicular to P1, P3. Therefore, this vector P1, P2 cross P1, P3 is perpendicular to the plane. Therefore, we can choose the normal vector n. Take n to be the vector P1, P2 cross P1, P3. Let's go ahead to compute the vector n. We need to find out what is P1, P2 and P1, P3. Imagine that you have an origin here. Then the vector P1, P2 is position vector of P2, which is OP2, minus the position vector of P1, which is vector OP1. Now OP2 is a vector 2, 3, 1. OP1 is a vector 1, 2, -1. So P1, P2 is equal to 1, 1, 2. You can see that P1, P2 is actually OP2 minus OP1. Next, we are going to find the vector P1, P3. Now P1, P3 is the difference between OP3 and OP1. You see that OP3 minus OP1 is P1, P3. Now OP3, position vector of P3 is 3, -1, 2. OP1, position of P1 is 1, 2, -1. This will give you 2 minus 3, 3. Having computed the vector P1, P2 and P1, P3, we are now ready to find the cross product of P1, P2 cross P1, P3. This is a 3 by 3 determinant with I, J, K in the first row and the component of P1, P2 in the second row, which is 1, 1, 2, and components of P1, P3 in the third row, 2, -3, 3. Then you can use the cofactor expansion to find this determinant, which is equal to I times the 2 by 2 determinant 1, 2, minus 3, 3. Then minus j times the 2 by 2 determinant. When you cross out the first row and second column, they will give you 1, 2, 2, 3. Plus k times the 2 by 2 determinant. After you cross out first row and third column, you get 1, 1, 2, negative 3. Evaluate the 2 by 2 determinant. This will be 3 minus 6 become 3 by 6 minus j 3 minus 4 plus k minus 3 minus 2. So in the end, this is 9i plus j minus 5k. If we use a bracket notation, this is 9, 1, minus 5. And this is a vector perpendicular to the plane. So we know the vector perpendicular to the plane is given by 9, 1, negative 5. We are ready to find the equation of the plane. You pick any point on the plane. Let's say the coordinate is given by x, y, z. Then we know that the vector P1P lies on the plane. And therefore, P1P dot n must equal to 0 since these two vectors are perpendicular. Now P1P is equal to the vector x minus 1, y minus 2, z plus 1. And the vector n is given by 9, 1, negative 5. And the dot product is 0. Carry out the dot product. I have 9 times x minus 1 plus 1 times y minus 2, which is y minus 2, minus 5 times z plus 1 must give you 0. And we multiply them out, we get 9x plus y minus 5z minus 9 minus 2 is minus 11, minus 11 minus 5 minus 16 will give you 0. And that is the equation of the plane.